Hello guys, let us start the post-contest discussion of CodeChef status 147. Let us see the first question, gold coins. In the first question, what they have given is the winner in a prize competition, winner gets A gold coins and loser receives B gold coins. And the game is played between only two people, chef and chefino. And what we are interested in finding out is how much money the chef has earned. And we know the scores of each players, both chef and chefina, which are x comma y respectively. If x greater than y, that means chef has won, and the prize money is A. And if chef has lost, then the prize money is B. And we are printing it respectively. Let us move forward to the next question. And the second question is Independence Day. In this question, what they have given is we have three colors: orange, white, green, which are denoted by A, B, C respectively. And what we are interested in is we have to arrange the strips in such an order that no two adjacent strips share the same color. No two adjacent strips should share the same color. What what we can do is we can find the cases for both answer yes and answer no. In which case for the cases where we get the answer no is that one color is more dominant than the other two colors in such a way that we can't arrange that we can't find a way to arrange the strips of one color which are which should be non-adjacent. But if the one color is dominant than the other two colors, then we can't arrange the strips in such a way that there are no two adjacent strips of same color. Let us take example like A is equals to 5, B is equals to 2 and C is equals to 1. If we place the both B and C alternatively to the strips of A, that means we will get the 4 strips and 4 strips of A for the 4 strips of B plus C, and there will be one strip of orange remaining which will be placed in the front or end, so that we can't avoid the placing of same color strips if the one color is greater than summation of the other two colors and plus 1, because as we try to place the strips at the end it will save us the value of 1. So what we have to check is we have to check if any of the value is greater than the summation of other two values plus 1. As if it is equals to the A is equal to B plus C plus 1, then it is possible that we can placement of it avoid the placement of same color strips adjacently. Like let me show you a fast example. Let me show you a fast example. Let us assume that black color is A, blue color is B, and green color is C. Here we have filled the 4 strips of A, 2 strips of B, and 1 strip of C. So we have totally covered all the strips of B and C and 4 strips of A, and there is 1 strip of A remaining. Whether we place it this side or this side, it doesn't really matter. We have failed to arrange the strips in a way that mentioned in the question. So we have to print the answer no only when A greater than B plus C plus 1. You may have the doubt that where this one came from. Where this one came because we will get an extra slot because by placing the values at the end of the our sequence. By placing the majority element at the end of the sequence, we can get this advantage of 1. Let us move to the third question. Here in this question, what we have to do is we have to find out which path leads to the which location. Here there are total of n plus m people, and n people will always tell the truth while m people always lies. We don't know, like, we know the number of people who says the truth and number of people who says lies, but what do we don't know is which person belongs to which group. So you can't particularly ask one person, like, if we know the person belongs to which group, then it is a pretty straightforward question. We can ask the person who tells the truth always, and we can, and the actual value will be always 1. But it is not the case here. It is not the case here. What we have to do is we have to find out the truth, and the truth should be like clear. It should be 100% sure that we know the correct location where the path leads to. And how do we know that? By picking the majority opinion. And we may, maybe the m greater than n or m less than n. It may varies. But if n is less than or equal to m, we can't say for sure that the majority opinion is right, because the majority of the people are liars. So you can't trust the majority people opinion, because maybe all of them mm all of the young people are liars. If the all of them people are liars, then taking the majority opinion means we are taking the wrong way. So we cannot decide in this case where n is less than or equal to m. We can say for sure only if and only if n is greater than m. In this case, the majority people in the whole group is truth. If maybe if all of the m people are liars, then the truth outweighs the false rumors. If n is less than or equal to m, that means the truth said by the n people can't outweigh the false said by the remaining m people. It's simply like truth and false means here like positive and negative sense here. So to outweigh the false rumors, we need at least one one value of the one person who one person at least more who says the truth. So in this case only we can particularly say sure that we can get to know that which path leads to which location. In this case we can't really decide which path leads to which location, because majority of the people are liars. As because that you can't trust their opinions. Now in this case what do we do is in this case what do we do is we have to find out the value of x. X means the minimum number of people you have to ask to get to know the truth. To find out the minimum value of x, what do we know that is m people may fully lie. M people may fully lie. It is our basic assumption in this whole solution process, because we have to exactly sure and we are taking the worst case possible to get through us through the all cases. And here, if we ask m people, then maybe all of the m people are liars and we may get the wrong way. If we ask 2m people, that means which includes m members of truth tellers, because maybe in this whole 2m people, maybe m people may are liars and m people may all are liars. But here there are also young people who tells the truth. Except the young people, the remaining people are truth tellers. So at least young people will say the truth. So it may leads to tie. For this, for the tiebreaker, we will need extra one person. So the x value is 2m plus 1. Here's the code for the solution. If n less than m less than or equals to m, we can't predict. If n is greater than m, we have to take the 1 plus twice of the false group. And for the fourth question, non-primes. In this question, they have given a array of size n. We have to find out the pair of indices I comma j such that a of I plus a of j is not prime. For doing this, before doing this question, what do we have to basically know is we have to know how to verify whether a number is prime or not. How do we check that? We check that if it is if the value is 1, if the value is 3, if it is divisible by 2 or divisible by 3. These checks confirm that none of the 1 to 6 well 1 to 6 number is factor of the given number. And after that, what do we do is we iterate from the fifth value to the root of the given number, as we know that the factors repeats themselves, and it optimizes our solution from big of n to big of root n for finding out the prime number. And after that, what do we do is we take majorly three cases. One is odd, odd, even, even, and odd, even. One thing we know is the summation of both odd and both evens, both are belongs to even. And we know that except 2, all even numbers are composite numbers. So we are searching for a composite composite number. We are searching for a composite number among these two combinations. Like we are dividing the entire array into two parts, where one set consists of odd numbers and another set consists of even numbers. And whether we check the number of events in the array is greater than or equals to 2. If it is greater than or equals to 2, we immediately print out the indices of the first two values in the set. In this, like, two sets means, here I will use the container map so that I can preserve both indices and the respective value of the value at the index in the array. I will divide it into the two maps, and in these two maps I will check whether the size of the map consisting of events is greater than or equals to 2. If it is greater than or equals to 2, I will immediately print out the first two indices available in my map. And if it is not, then I will go to the odd and odd set. Odd and odd. And in this what do we know is except only once if we add any other prime number, it results to a any other odd number, it results to a composite number. Example, 1 plus 3 4, 1 comma 7 8, 1 comma 5 6. So that except 1 comma 1 leads to 2, as it is the only way to get the 2. So if there exists only any value other than 1 in while the size of the odd numbers is greater than 1, that means maybe the other, we have at least one value not 1, that means maybe the other value 1 or any other odd number, we will get the composite number definitely. So what I have to check is, let us take a value at the front. The value may be 1 or any other number. We will check the summation of uh, these value with all other values in the whole map and check whether it is not prime, and if it is not prime, then we print out the indices of the both this index and where we found the matching index, such that both of the sums are not prime in the odd set. If we are unable to find, if we are unable to do so, then we immediately return -1. After these two cases, what we have to do is, we have a third case where the size of both even and odd is less than 2. Both of the even and odd sets are less than 2. That means there is one element in each set, because one constant is given is number of values in the array should be greater than or equals to 2. So there exists at least one value in the even set and odd set. So what we have to do is, what do we do is, we simply take the sum of the both values in the both sets and check whether the sum is prime or not. If it is prime, then we return, then we print out the value -1. If it is not prime, then we print out the indices 1 comma 2 respectively. You can see it here. Here it is the division of the array into two sets, and here we are checking whether the size of the even values set is greater than 1, and if it is greater than 1, we are giving the first two values in the set. Otherwise, we are going into the set of odd numbers. In the odd number set, we are checking whether the sum of the both numbers are prime or not. If it is not prime, we are printing the indices. Otherwise, we are printing the -1 if we unable to find the value of any pair such that their sum is not prime. That means all of the odds in the set are maybe only ones. After that, we proceed into our third case where we have only one element in each section. One element in each section, that is array of 0 and array of 1. One is odd and another is even. We check whether the summation of the both values is prime or not, and after that, if it is prime, then we are printing -1. That means there is no composite number in the whole array. Otherwise, we are printing 1 comma 2, as it is, as the summation of 0 comma 1 indices are is not a prime and it is a composite number. So in this way, we divided the problem into totally four categories. One is odd and even and even. Odd and odd, even and even results to even number, and we know that except two, all other even numbers are composite numbers. So in this way, we have eliminated, and after that, if we have only odd and even, one odd and one even number, then we try to do the summation of the both numbers and check whether it is prime or not. If it is prime, then we printed the just first two indices. And one thing to note here is, here the output may slightly vary from this output. Here we get 1 3 in the example, but by running this code you may get output 2 comma 4, which you don't need to worry because 1 comma 3 is 4 here and 2 comma 4 is 6. It doesn't matter, no, either way you go. But the thing is, they accept all type of variations in the solution. They may, like in this, so there is no need to worry if your output slightly varies from this output. What you have to check is whether the indices, the sum at the indices of the sum of the values at the both of these indices is whether composite or not. I think that concludes the fourth question, prime non-prime.